Okay, so now we are on section 9-3, which is triangle congruence. And there's different ways that you can tell whether triangles are congruent or not. So, and they have different initials. And the first two that we're going to look at are side, 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 and side, angle, side. So you will see them as SSS and SAS. So I'll give you an example of two triangles that are side, side, side. So there's triangle 1 and triangle 2. Okay, and so let's label this triangle A, B, C, and this one can be D, E, F. Oops, I did that wrong. D, E, F. So anytime I have two triangles that have exactly the same side length, there's only one way I can put those two triangles together. So all of their angles by default will be the same, no matter what I do. There's only one set of three angles that these two triangles can be. So if I have three congruent sides, then I have two triangles that are congruent, and all of their sides and angles therefore would also be congruent. So the way I would write that is I would write triangle ABC is congruent to triangle DEF. Sorry, would that be? Yeah. Okay. Side angle side you can kind of think of as the Oreo cookie of triangle congruence, because it's funny. Abby's laughing at that one. Abby's just wishing she had an Oreo right about now. Have you ever heard Mr. Rowe give that explanation for side angle side? It is the so what that means is that you've got two sides that you know are congruent and the angle in between them that you know is congruent. So again, we can label this ABC, DEF, and I know that these two sides are congruent and the angle in between is congruent. So they are side, angle, side, side, angle, side. So I could say that triangle ABC, I'm going to do this first side, angle, then second side, is congruent to first side, so DE, angle, and second side. Okay, triangle, there we go. So they might say, well, let's see if angle, angle, angle works. So an easy way to think of that is, and I'm going to use something that's a totally different shape to prove the point. So if you look down at the top of that, there's a square, right? That's a certain size and dimension. And there's a square. So they have the same angles, right? They're all four 90-degree angles, but they're two completely different sides. So is that square congruent to this square? Obviously not. This one's much larger. They're similar, but they're not congruent. So in order, let's look at a triangle now. So let's say I make an equilateral triangle. And of course, this is a perfect equilateral triangle because Mrs. V draws perfectly, obviously. So that's an equilateral triangle, right? And by default, it's also equal angular because that's a 60-60-60 triangle. Oh, look, there's another equilateral triangle. Oh, look, there's another equilateral triangle. Okay. They all have 60-degree angles. Are they congruent? No, they're not congruent because the sides are different lengths. Okay. They are similar, which is fine, but when we're dealing with triangle congruence, we have to deal with only congruence. Similar doesn't help us very much. Okay, so we're going to do some practice problems down here. You're going to do this in class also on Monday with a whole sheet of basically pairs of triangles, and you're just telling me whether they're congruent and if they are, why they are congruent. So let's go through and do some practice on these. So here I've got side, which is my long leg, side, Sorry, actually, that's my hypotenuse. Side, side, side. So yes, those are congruent by side, side, side. Here, I only have two sides, but if we look at that as two angles right across from each other, we know that vertical angles are equal. So we know that those two angles are equal. So now I've got side, angle, side, and side, angle, side. And what you want to double check is, I know that my 2-tick side is my short side of each triangle, and my 3-tick side is my long leg of each triangle. So I'm okay there. So I have side, angle, side, angle, side. So yes, they are congruent by side, angle, side. Now here's kind of an interesting case, because you've got two sides that you know are the same. You have an angle that you know is the same. But here you've got two triangles that are sharing one side. So think about this logically. What do you know about this side of this triangle and this side of this triangle? Well, they're actually the same thing, aren't they? They're the same line, which by definition means it has to be the same. So now you've got side, angle, side, angle, side. So we kind of call that reflexive property. When that line's looking at itself in the mirror, it sees itself right back. So we call it the reflexive property. Okay, meaning the line is the line. All right, so let's go down to our fourth example. And here we know that our angles are congruent. Angle, 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 angle. So we do have angle, 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 but that we just went through up here. Angle, angle, angle tells us similarity, but they are not congruent. Okay. Angle, angle, angle makes them similar, but not congruent. It's an important distinction. Okay. On these last two, go ahead and try this on your own and then come back and check your work. Okay, so again on this one we know that that side is the same for both. So we have side, side angle, and side, angle, side. So those are not going to be congruent because we don't have that angle sandwiched in between the two. We actually don't have enough information yet to know that. You might know that in the next section, but right now you currently don't have enough information for that. Okay, in this one we know that that side is the same, and those angles are the same, but we don't know anything about that third side, and we don't know anything about this side or these angles. So for now, we don't have enough information to prove that. Okay. Remember, it's really important in geometry. It's not what you assume, it's what you can prove. Okay? Good. Speaking of proving, it's Abby's favorite part, proofs. Abby loves proofs. Loves them. Wish she had a whole class of nothing but proofs, right, Abs? She's a very good actress, too, by the way. Okay, so let's remember, when you're doing proofs, you're always going to be given something. And that's the first bit of information that you put down. So H is the midpoint of GT. Remember what midpoint means. It means it cuts that line in half. Perfectly in half. And that means that each side is the same. So we know that those two sides are equal to each other. Hi, honey. Okay. HR is congruent to IH. So we also know that we only need two tick marks, that those two sides are equal, are congruent. Okay? That's what we're given. So we're going to go down here and say we were given that. Okay? So let's see what else we know. So let's look at our sides first. Well, we know we've got a third side sitting there, but we don't have enough information right now to say anything about that. So let's put what we're trying to prove down here at the bottom. We're trying to prove that triangle GHI is congruent to THR. Okay, so we're trying to prove that GHI is congruent to THR. I don't have enough for side. I might be able to figure out an angle. What do I know about these two angles? They're directly across from each other, so they are called what? Those are vertical angles. So the angle GHI, so angle GHI is congruent to THR because they are vertical angles. Okay, so I can put that in there. I actually at this point have enough information now to have that. Okay, I know that they're congruent because I've got side, angle, side, side, angle, side. I've already proven what I need to prove. Okay, side, angle, side. I don't even need that third reason in there. Okay, let's go down to the next one. So given that ACB is an isosceles triangle, so that's going to be an important word for us, with base of AB, and CP is an angle bisector. So bisector, that's not really a term that you've necessarily heard yet. Bi means two, right? So that means that cuts the angle in half. Again, which means that there are two equal angles. Okay. So I'll state down here what we know. So we know that ACB is isosceles. We're given that. Okay. The second thing that we know is if ACB is an isosceles triangle, that means the two outer legs have to be the same length by definition of an isosceles, which tells us that two sides are the same and the two corresponding angles are the same. So side AC would be congruent to BC. And we know that because that's the definition of an isosceles triangle, right? What's the next thing that we know? Well, we know that we were told that angle 1 and angle 2 were created because we bisected angle C with that CP line. So we know that angle 1 is congruent to angle 2 because that is the definition of an angle bisector. It means it cuts it right in half. So whatever that measurement is, it's the same on this side as it is on this side. Okay. We also know that this line CP is the same no matter which triangle it's attached to. So CP is congruent to CP, and that is, remember when it's looking at itself in the mirror, we call that the reflexive property. So now let's see what we've got when we get all done. We've got a side, an angle, and a side, and a side, an angle, and a side. So yes, those two triangles are congruent. So, and that's what we're trying to prove. We're trying to prove that ACP is congruent to triangle BCP, and now we know that it is by side, angle, side. Okay? Really not too hard when you get right down to it. So let's just say a couple more things about isosceles triangles, and then we will be done with this whole section. Okay? So let's talk about those properties of isosceles triangles. So one is if a line bisects the vertex angle of an isosceles triangle, then the resulting two angles are congruent. And think about why that is. That's a definition of something that bisects something else. It cuts it directly in half. So in our triangle here, we have triangle that AC is congruent to CB, which makes it isosceles, right? So angle 1 has to equal angle 2 because that is a definition of an angle bisector. Okay. The interesting thing that also happens is that comes straight down. That's a vertical line. It actually creates two 90-degree angles. Okay. The other thing that you know is that these end up being congruent because the bisector also split this right in half. So the two things that end up happening are AP, the segments down here are equal. So AP is congruent to BP, and angle APC is is also congruent to BPC, and those equal 90 degrees each. So it's kind of an interesting occurrence that happens, but it makes isosceles triangles really easy to use. That's it. That's 9-3.